Hello everyone. Welcome. Welcome back. So today I'm rather late. Um Not really, but anyways, the days are becoming really short, and it takes less and less time to finish a lot of things. Anyways, no, it takes a lot of time to finish a small task. In other words, time is really running fast. So, so today we are going to solve a couple of questions. Yesterday I solved two questions on linked lists, and I solved two questions on linked lists, and um, sorry, that was somebody came in. Anyways, yesterday I noticed something strange. Apparently, there was a. Anyways, I'm not allowed to say that, but all right, guys. If you have any questions, you can ask me, and I'll try my best to answer them at the end of the stream. If you have like very personal questions, otherwise, if you have a question related to the problem I'm solving, or you have a suggestion, you can also, you know, chat in your suggestion in the chat, and we can revise the question and see which other approach is better to solve the question. All right, so here's a question, and I haven't even practiced this question. I've not even solved it, but I think I'll just try and see how well I'll do with this. So let me check the chat. Hello, Ransom. Nice to have you here. You're welcome. How are you doing? All right. So, and every other person in the stream, you're welcome, guys. Nice to have you again. So, we are approaching the end of this 100 days. So, this is day 87, which I'm really excited for. And at the same time, yeah, it's just mixed feelings, anyways. So, let's jump right into the question and start solving instead of talking too much. All right, so we are going to start. I would love to start with the easy question, then gradually get to the hard one or medium question. So I chose um lit code number 160, intersection of two linked lists, which I also haven't solved, but I read this question, and this question to happy number, which is rather a strange question. But anyways, we'll see how we'll go about it. Okay, let me start with the happy number problem first of all. Then we go into, let me see how I linked it here. I added, okay, reverse words in a string. I think that this question will be more interesting, right? So let's start with the harder one first, and then we'll go into much difficult ones. We'll then solve the easier ones. Sorry. Okay, I don't know. My brain is really lagging right now, and I don't really know what I'm saying. Okay, so I'll remove this from this place. We'll solve that question again, maybe tomorrow, to, help revise and remember the techniques used to solve the question. That was I think summing the nodes in a linked list, in two linked lists simultaneously. All right. So here is reverse words in a string. It's a medium question and it is related to two pointers. I think I chose the question from the two pointers algorithm list. So we'll use this instead. All right. I'll bring this here. Okay. Now reverse words in a string. Given an input S, reverse the order of the words. A word is defined as a sequence of non-space characters. The words in S will be separated by at least one space. Return a string of words in reverse order concatenated by a single space. Note that S may contain leading or trailing spaces or multiple spaces between words. The returned word should only have a single space separating the words. Do not include extra spaces. So here is an example input. We have the sky is blue. Then we want to return it in the reverse order, right? Which is going to be blue is sky and then the. So the sky is blue, blue is sky, the. And then in this case, you can see we have a second example. Now, in this case here, we have trailing spaces, right? You can see there is a space in front and behind. So the resulting word should not contain trailing spaces, as the question says here. And we also need to reverse the word in this words S. Or S. S is just a group, a number of words stored in a string, and we want to return those words in reverse order. So instead of hello word, we'll return word hello, and then we remove all trailing or leading spaces. Now, here is another one. We have a good example. So a good example has more than one space here. Okay, so you can see this is really funny, meaning we also have to remove the extra space and return example good A, and then separate each one of them by single space. So no multiple spaces, no leading space or trailing spaces, and reversing the words in the string, which is what this question is asking us to do. So how do we solve this? So I'll create a file. Let me come here. This is going to be in the two pointers folder. It's LeetCode 160, right? 151, okay. 151. Two pointers. So this is a new question. I'll call this Leet dash 151. Okay. 151, and it says what? Reverse words, right? We are reversing the words in the string. So reverse word in the string, so put this here. Just give me a minute. I'll be back. All right, so okay, so here is what I've created the file for this question. We'll copy this part. Now, before we solve this question, right, we need to understand how reversal of a string works, right? So how do we reverse a string? Well, let's just do a little exercise. So I'll write s here equals to hello, hello, like this. And so let's see how we can reverse hello. Now, to reverse a string, we know strings are not mutable, right? Meaning we can't, add a character to a string just like that by doing something like this. Let's say s dot. You can see there's nothing like adding, a character to the string. But if we want to reverse a string, we can iterate through the characters of the string and add it to, let's say, a new string, right? For example, let's say this will be our result string. Let's say I'll call this res. Res is going to be an empty string, right? And we'll say for let's call this st, or let's call this word, and I'll say for character in word, right? So we can do this. We can say res. So we can add the new character to res and then add res back to res. So we can say plus equal character, and then we can just say plus res, right? So plus res like this. Come on, what's this? Services. Okay, so let's print res at the end of the day. So say print res like this. Okay, I added this a lot of times. So let's say, first of all, let's print each character. So print character for every character in word. So you can see hello, hello, HELLO. Now, sorry, this is not what I should have done. So now you can see we reverse the string. Let me remove this part. So we just reassign a new value to the string, right? We reassign a new value to the string by appending the current character and the previous values we already append to the results, right? So if we do this, you can see hello, we now have OLLEH, right? So we reverse the string this way. Now, so again, like I said, strings are immutable. You cannot do something like this. Res, let's say word at 0 will give us the first character, right? But we can't say word at 0 is equal to something else. Uh, let's say 8, for example. This is not possible. Strings in Python are immutable. If I run this now, you see we'll have an error. We can't do this, right? But arrays are mutable, but strings are immutable. You can't mutate strings. You can't mutate characters in a string. So let's see if I just heard something. Maybe I have some question. Um, oh, okay, you don't understand. All right, let me explain. So we are trying to reverse a string. In other words, we want to return the reverse form of this word here, which is hello. Now, to reverse a string, we simply reassign the reverse form of the string. So we iterate to a new string, sorry. Because we cannot reverse the string in place, right? At least for now, we can't do it now. Hold on. So at least we can't do it within the same string, so we have to unpack it into a new string, which is what I did here. So we'll take this string which is empty, and then we'll add the characters, right, one by one from this main string here to our new string, right? And this will return the reverse form of the string. Now, how do we return the reverse form of this string? When we append this character, the first character of word, which is h, to res, right? And then we add back res to what res used to be. Res used to be 0, used to be empty initially, right? So in the first iteration, we'll have something like this. We'll have h plus, sorry, h plus an empty string, right? And then we assign this to res, right? H plus an empty string will be assigned to res, and in this case res becomes something like this. Res becomes, let me use an arrow. So res is now equal to h, right? Because we know h plus an empty string is typically going to be h, right? Now in the second iteration, this is 1, right? This is first iteration. In the second iteration, 2, okay, this is 2 here. In the second iteration, we know res is already h, right? So we'll do the same thing again. Now the next character in word that we'll look at is e. So we add e to res and then assign the previous value of res to it. So we'll end up with something like this. So we'll add e, right? E plus previous value of res. Previous value of res was h, right? So we add the h to res and then we assign this result to res. So res is going to be equal to eh. So we'll have e and h, right? And we'll do this in every iteration. Now you can see we are beginning to have the reverse form, right? The reverse form of the string taking shape. So in the next iteration, which is going to be for the next character in the word, I'll put 3 here. We'll have the next character will be what? It will be L. So we'll do for L, and then we'll say L plus the previous value of res. The previous value of res was EH, so we'll add EH to L, and then we'll end up with res being equal to, we'll assign this to res, so we'll have LEH, right? And then we'll do another iteration again. We'll go through another iteration, which is 4. Then we'll take the next character again, which is L, and then we add it to our res. So the previous value of res was LEH, and then we do this again. We just take this part and say res equals to LLEH, right? And as you can see, this is how we'll end up with the reverse form of the string. So instead of having hello, right, we can just run this function and have the reverse form of it. Now, the reason why I did this is because of this question, right? This question is asking us to reverse the words in a string. We just saw reversing characters in a string, which is every letter in the string, right? But we want to reverse the words in the string. So how do we do that? Well, again, there's going to be some element of iteration, which is, already at the back of our minds. But before we do that, right, I would like to first of all use a 2-pointer method to reverse this string. Now, with a 2-pointer method, we'll need a pointer at the beginning and a pointer at the end of the string. And every time we iterate, right, we'll swap those values. So let me show you what I mean by that. I'll take this here. Oh, sorry, I forgot to ask if you understood the question. Let me check. Um, okay, all right, okay, you understand now, right? Okay, thank you. You're welcome. So let's move on to the two pointer method of reversing a string. So I'll take a string here. Let me remove this stuff from here so that my space is clear. And okay, so here is oh we have we have a string. Let's call this hello again, right? HLLO. This is our string. We want to reverse this string using the two pointer method. Now with a two pointer method, we know we have to put one pointer here. I'll call this I, or let's call this left and right, right? So the left pointer is at the beginning and the right pointer is at the end of the string, right? Now, what I'm imagining or what I'm thinking about doing is to simply take the character here, right, and then swap it with this one here. So we can do something like this. In Python, you can swap the position of two items in an iterable, or in a data type that you can iterate through, right? So let's say, for example, an array. So we can do something like this. We can take, if this was s is equal to this, then we take s at l, right? And then we take s at r. Then we swap them by just putting s at r here and s at l here. So this way we will swap the values. So this here becomes that, this points to that, and this points to this. And with the two pointer method, the condition is such that as long as the left and right pointer are, you know, the left pointer is less than the right pointer, we can shift the left pointer towards the right pointer and shift the right pointer towards the left pointer. So let's say um so in this case, I don't think it will work directly for strings. At least let's take a look at something here. I just bring this here. I don't think so, because we'll probably need to, transform this string into an array, right? And then we iterate through that array to, so let's say, um, I'll put this L. L is equal to word at 0, right? And then R is going to be equal to word at len of word minus 1. Len of word minus 1. Let's do it this way and see what this will give us. I'll say print L and R. L and R. Let's just see what they are. If this works, this will be H and this will be O, right? So let me print this. You can see it's not callable. Oh, sorry, I used this. Okay, this is what I'm supposed to do. All right, we can see we have H and O, right? So can we do something like this? Can we say word at L? Like I said, strings are immutable in Python, but I don't know if this will work. I've not tried it. So word at R is equal to word at R and word at L. I don't think this is going to work. So okay, L and R are not this. So let's just say this is 0 and this is going to be the length of the word minus 1. I'm not sure, but let's print the word at the end of the day. If this works, then it is good. So print word. All right, as you can see, so strings are indeed not mutable in Python. So strings are immutable. You can't directly mutate the values in the string. So which means we'll have to transform this word, right, into an array, right? So to transform this into an array, we can use the split method. So let's print word dot split, right? So let's just split this. I'll just remove this part. Let's cancel this for now. Now you can see this is just returning. So let's split with this. Okay. All right. We can't split the characters like that, except there was a space. So this will still return. Otherwise, the only thing we can do now is to iterate through the strings and add each value to the array, to an array, right? So let's say we had word r. I'll call this word r, and we can just do something like this. We can say word r is equal to an array. I'll just say, just put character for character in word, right? And then let's print this and see. Print word r. Yeah, okay. So we use a list comprehension here to print every character. So now we have each character in the string. So here I can mutate this, right? I can say word r. Let's just put word r here and word r, and I'll put word r here, right? With this we can swap the position of each word. So I'll say word. Let's print word r at the end of the day. So now you can see h left this position and it's at the end now, and we have 0 or o at the beginning of the string. Oh, thank God, I still have my chat open in front of me. I totally forgot. Yes, I can use lists. Thank you, Ransom. I can use lists as well. This is awesome. Thank you very much. So we can use lists like this and transform it into word, right? This also works. Yeah. All right. I just forgot about lists. All right. So with this, we can iterate and swap the position of every character in the string, right? So we can use a 2-pointer. So let's say while, I will do something like this. I'll say while left is less than right, which is r. We can say do this. Do swap this word, right? And then we can just say increment left and right. So say l plus equal 1 and r minus equal 1. Decrease right. So just do it this way. Okay, let's space it out a little. I don't know why PyCharm is so, insisting on stuff like that. Wants trailing spaces. Why is this thing here now? Okay, so now we can iterate and increment the left and right pointers, right? So in the end, we should have a reverse form of the string. So I'll just print this. Now you can see every character in the string has been repositioned. If we print this as a dual string. So I'll just say here, I can do something like this. I'll say this dot join word r, right? So we'll transform this back into a string. So now you can see we reverse this string just using a two pointer method. Now the reason why I'm doing this is because I'm slowly driving at the solution to this question, right? Now we just saw how we can reverse a string, right? We can reverse a string. Okay, imagine if we had let's say trailing space. Okay, this will not work in this case, so let's just forget about it. So we can use two pointers, right? Now the only thing we need to do is to avoid trailing spaces and extra spaces or multiple spaces between the words. So how do we remove trailing spaces from strings in Python? I think do we have, is it trim? At least in JavaScript we can use the trim. But let's see, in Python is what? I'll just take this. Let me print a string. I'll call this str. Okay. I'll say word w. Okay, let's just leave it as w. And then I'll do something like this. I'll say hello, hello like this. So I have two spaces. And let's print w dot split what do you use? Let's see, what do you use? Yes, there's strip. So you can strip the this from it. Okay, now you can see we no longer have trading spaces, right? If we printed this directly, you can see we still have the trailing spaces beside it. But with the strip method, right, this will be removed. Okay, which is one of the methods we'll use, or techniques, right? So let's see. Okay, Ransom has a solution: split and reverse. Yeah, I mean, this I'm not sure. So we have strip. Okay, we strip all the extra spaces, and then we split it into an array of strings, and then we copy out the reverse back into the string s. Okay, this is awesome, right? This is awesome. But okay. I would like to use the two pointer method first, and I think this method, okay, you know what, this is a one line solution, right? But I'm sure there are some edge cases there. So let's read this and see. What if we had extra spaces, right? What if we had, let's say, two spaces like this? What will happen? We still have two spaces. So when we do this, let's say we strip, then we copy back the reverse, right? Strip dot strip, split, and reverse. So split, right? And then we copy back the reverse form. So let's do this first. Let's try Ransom solution. So this is going to be -1, right? Let's print the w here and see what's going to happen. As you can see, we have oh, what is this? Is this an empty space, right? So meaning we still have our trailing space here. Or it's not. It isn't. Okay, okay, sorry. This is so confusing. Okay, it means this works, right? Even if we had extra spaces, it will still work. Okay, okay. Yeah, this a good solution. Let's try this out and see if it will work. So we just return, so one line solution, return s um s equal, okay, so we need to join this back, right? We need to transform this back into a string, so we can just say this dot join, come on, join s dot uh, strip, we strip this, okay, then we split, right, and then we take this from here, -1. Okay, so let's see, let's submit this. Oh, okay, I didn't need to do this. I just need to return this part. What's happening here? Wrong answer. You see, okay, we need to join it by space. Okay, sorry about that. Okay, this works, which is good. So let's submit this and see how this will do. Okay. Congratulations, Ransom. Yeah. All right, so let's try the two-pointer approach. Right. So, um, so with this, we can use the two-pointer approach to, you know, swap the values, right? So let me copy this part of this question. Let me copy this part. And we can put this here. So I'll just bring this here. Okay, so here's our solution. So here's what I'll do. I'll call this res, because I want to get the left and right pointers at each position. So let's say res is equal to s dot strip. First of all, strip all the white spaces, strip all the trailing spaces, and then split it. Split like this. Okay, so we set our left pointer L. I'll call this left to be equal to 0, and our right pointer will be equal to res dot, res, the length of res minus 1, length of res minus 1. Right, so we'll say while L is less than right, okay, so we simply, let me close this part. While left is, I still use L, I want left. Left is less than right, then we begin the swap, right? So we say res at left, I hate this cursor. At left, and you know, we do the same thing for right. So res at right, so we'll say is equal to res at left, res at right before left, so right and then left, res at left. I don't know why I'm typing like this. Okay, so here is what we can just do it this way. All right. Okay, So then we increment the left and right pointers, right? So we increment and decrement. So left pointer will increment by 1, and right pointer will decrease by 1. So then, yeah, so at the end of the day, left will be equal to right at some point while we are iterating. So we can then say, now we've reversed the strings into res, so we need to return res as a string. So just say this dot join, so return dot join res, right? So yes, this is, we return the array as a string like this. So let's test this out here, and I'll just okay, I think I have a question. Are you preparing for coding interviews? uh I I'll say yes and no. Yes, because in the future I will be interviewing, so I need data structures and algorithm. But at the same time, I'm just studying data structures and algorithm to prepare ahead, right? So as he's preparing for the few with future photographers. Okay. So let's go. I think that is the answer to your question. Feel free to ask any question if you want, and I shall answer you. Okay, so we have the solution. Let's print what we get here. So I'll say solution dot reverse words. Let's copy a word here. Then let's see. Dun, 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 dun. I'll copy this. No, I want to copy the one with the trading spaces. So let's see what we get. Uh, uh. Hello, Comfort. Thank you, thank you, thank you. Da, da, da. Word hello. Yeah. Okay. So this works. And let's submit this to. Let's. I mean, this will take O of n space because we are creating a new array with res, right? So this will increase the space complexity to O of n, and the time complexity for the runtime for this solution is still going to be O of n, right? Because we are iterating through every word in the word string. So yeah, let's paste this here. Okay, I copied this, so let's just do it this way. This work, this work, yeah. Dun, 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 dun. Okay, so I probably caused an issue. Yes, I did. I did. Alright, so let's run this again. Okay, this works. Okay, as you can see, you see the space here is really high, which is 16 compared to the previous submission. Surprisingly, the time complexity for this is actually ranked higher than the other one. Again, I usually say this, right? This doesn't really matter. Honestly, you shouldn't beat yourself about these ratings because it is not consistent. You can see this is 16.64, right? And this is 16.75. So how is this 17% and is this is 16%? I don't know. I don't know. That's really crazy. If you calculate this, this is not even close to being 17%. At least this should be like 50% or so. But anyways, I don't know how Let's Go does their rating, which is really strange. So it doesn't really mean anything to me as long as your solution works and you know what you understand the time complexity behind every solution and so on. I think you're good to go, right? So all right, so let's move on to the next question. Now this question is done, uh, which is awesome. Wow, it's 12 minutes to closing time. Hoo, hoo, hoo. At least I think you guys understood this question, right? Which is, it's better to understand a question really well than to understand, you know, a lot of question on a surface level. Anyway, so let's move on to the next question. Intersection of two linked lists. I read this question and I thought to myself, who did this? Shorter doesn't mean faster. Yeah, yeah. Okay, so we are given two linked lists. Given the heads of two singly linked lists, head A and head B, return the nodes at which the two lists intersect. If the two linked lists have no intersection at all, return null. For example, the following two linked lists begin to intersect at node C1, okay, here, and the test cases are generated such that there are no cycles anywhere in the entire linked list. I remember I solved a linked list question that has a cycle in it. That question, I just I just didn't revisit that question. That question was actually very, very interesting. Anyway, so let's continue with this question. So, I mean, these are like descriptions to the question. Since time is, not on our side, let's just continue to this part. So here's um an example. We are given two linked lists. So this will be the first linked list. I think I have a hold on. Where is it? Where is it? Oh, hey, hello, Gabriel. Hello, nice to have you here. Welcome, welcome. Oh, okay. I recently downloaded this thing to write on the web. Wow, this is good. This is very, very good. Okay, you can't do like that. You can take this part. Aha. I don't think I'll be needing this board anymore. I think I will need it. Will I? Do I need it really? I'm not sure. Anyway, so we are given this linked list, right? So here is um the first node. The first node is like this. So let's write 4 to 1. Oh, this is the only annoying part. I have to go and do like that. Ah, we have 1. Come on. We have 8. We have 4. And then we have 5. Like this. Then we do the same thing here. So we have 5, 6, 1, 1, 8. Okay, you know what? Maybe this is a bad idea. It is a bad idea, I agree. I agree. So let's shut this down. This is not the use case for this at all. I still need my board. Okay. So exit. Thank you. All right, so let's bring this here, and I'll put this here. Let's use the board, the almighty Excalibur board. Okay, yeah. So we want interception of two linked lists. Well, I think one way we can do this is to simply, I don't know, we can't say we'll iterate through the list simultaneously. At least for now, at the top of my head, I am not thinking about that. All I'm thinking about is to traverse one list, store the values of that list, maybe in a dictionary or a set for that matter. So we can use a dictionary or a set, and then check, iterate the second list, right, to see if any node's value has already been stored in our set, right? So let me draw the list again. We have 4 1 8 4 5, right? And then we'll do the same thing here. We'll say 5 6 1 8 4 5. Okay, so we can iterate the first, we can traverse, we don't iterate, so we traverse the nodes of the first list, right? And then store, can we store the nodes directly in a set? I don't know about that, but if we can, then we store each node in a set, right? So we'll have a unique node, so of each node here in a set. So let's say we traverse the first set, we'll have you know, four, let's use a blue color. So we'll have 4 1 8 we can't add 4 again because 4 is already there, and 5, right? Then we traverse the second list. Okay, we traverse the second list and find out if any node in the second list already appears in our set here, right? So this is our set. So we'll say so here we'll check for the first iteration while iterating through the second list. We'll check if, let me put I here. So if node at this point is already in the set, right? So if it's not, we continue our iteration and we keep searching. So we'll move from this point to this point. So 6 is not in the set, we continue. 1 is not in the set. 8, sorry, hold on, 1 is already in this set, but 1 is not where they intersected. Ha, interesting. Interesting. You see, the problem here is that one list is longer than the other, right? So how do we go about this? Because 1 is not where they intersected, right? This is not where the intersection happened. It happened after this place, so it's not really when the values are equal. So what is it then? Oh, wait. I think it's actually when the values, when the nodes are equal instead, not the values, right? Because if I said this node, even though they have the same values, right, they are not the same, because the next node of this node is 8, which is also the same for this node. But if you look down, right, if when you look at how nodes are stored, when you print a node, it's not really the value that comes out. It's like an encoded version of the actual value. So let's create a file for this question. Um, I don't think this is what's going to happen, but let's try it out and see. Let me commit this question first. So let's say git add, sorry, git commit. Lit. So this is a two pointers problem. Two pointers, and this is going to be lit code dash 151. Yeah. Okay. So that has been committed. Let's create a new file. This is a linked list question. Is lit code 160 intersection of two lists. So linked list. Oh come on. 160 file lit dash 160 dash intersection of two linked lists. Okay, so let's solve this one. First of all, I'll try creating a node and printing what that node looks like, right? And let's just do an experiment. So we have value list node. Okay, so they are tired of writing file all the time, so it's just S now. Interesting. So let's create, I'll call this n1, which is node 1. So I'll create a node, a list node, and set this to 1, right? And I'll create another one called n2. I'll call this list node 2. Okay, so let's print n1 and n2. Let's see. Print n1 n1. Okay, let's just print n1 and see. In fact, let's print both of them. If this works, then I know for sure that I can use a set to directly store the nodes in the set, right? And then we'll have unique nodes despite the nodes having the same value, right? They are not stored this in the same way. They don't have the same next pointers, right? So let's see. You can see we have an object which is printed, and this like some random stuff. I don't know what it is, but I'm pretty sure they are not the same. You can see this one ends with 50, this one ends with 10. So meaning there's a chance that these stuffs are unique, right? So let's say we have one like this. You can still see they are still dots. Okay, let's print let's say new set. I'll call this new set. New set is going to be equal to set of n1 and n2. N1 n2. Okay, I can just pass it as an array, right? n1 and n2. Okay. Can I do this? Yeah. I think we can directly pass them like this. So let's print set and see. Print set. New set. Oh, exactly. Now you can see these are still unique objects, right? So you can see the set stored them separately, which means, yeah, it is actually two different stuff. So nodes, when you store nodes directly in a set, they are not equal at all, right? Okay. So which means we are safe to use the set to store the values of the nodes. Um let's go said, which late code question is this? Okay, so the question is late code 160. It is linked in the description in case you want to read it. It is intersection of two linked lists. So we are trying to find the intersection of two linked lists, right? All right. So the another reason why we need to use this set and store directly the and store the nodes directly in this into the set is because we are trying to return the intersected node, right? At the end of the day, we want to return the intersected node, which is at 8, right? 8 will still have its own next pointer pointing to another node and so on, right? So which is what we are trying to do here. So we are trying to return 8, not the value 8, but the node 8. The node 8. So, how do we do this? I can come here. Let me remove this part of the question. Let's try to. I'll copy this part of the question and try to solve it here. What? How did you end up there? Okay, so let's take this, remove that. Okay, we are given two nodes. So I'll say I'll traverse one node and then store every value of that node in a set, and then I'll traverse the second node to find if any node of that second node is in the set, right? And if it is, then we return the node. Otherwise, we return none at the end of the day. So here's what we need to do. I'll call this node set, which is going to be equal to a set, and we say current node. I usually do current node all the time. I don't know why. It's actually, it's not like I don't know why. I actually know why. The reason is it just keeps track of the current node while we are traversing the list. So this is going to be head A, and they will say okay, while there is a current node, right? And in other words, while the current node is not none, then we can say current. So we store the nodes. So node set dot add current node, right? Then we now set current node to the next node. Current node should be equal to current node dot next. Okay, so this way we've stored every value in the node of the first list, right? We stored every node in the node set of the first list. So the second list, we'll do the second list again. So we'll say while. So we can use current node again, or just say current node. We'll say for head B. I will say while there is a current node in head B, then with that compare, right? So say if current node is in if the current node is in node sets, right, then we just return current node. Otherwise, we just continue. So current node is equal to current node dot next. Okay, And then we can, if we don't return anything in this loop, right, in this second while loop, then we have to return none. I think, is it none? uh is it guaranteed that there is at least a solution? Can you write a solution that runs with o m plus n time and only use uh, a constant memory? Hmm. Okay, we'll come back to that. But let's see, what else do we return when there is nothing? You know what, let me read this part. Okay, return null. So we can return none. So else return none for now. Okay, this is going to give us some warning, but it is good. We are good with this, so I'll just bring this here. All right, let's see. I mean, this already means that we are not doing this in constant memory, right? O of 1 already, it's a no. But anyways, let's see how this turns out. Is my time up already? Let's check. Oh, whoa. Since I'm behind time. All right, let's quickly. Oh, okay. The solution worked. Uh, aha. So one lesson learned today: you can store nodes in a set, even when the values of those nodes are the same, right? It will still store a unique version of that set. So each node in a linked list, even if the nodes have the same values, they are not the same. Lesson note to self. So you can store any nodes, two equal nodes in a tree, in a linked list. I would not, there's no equal nodes in a linked list at least, but when there are two nodes in a linked list that have the same value, it does not necessarily mean that they are equal, right? They are only equal not only by their values but the next node attached to them, right? Which is why the intersection did not work at this point, right? Because we know after this node we still have more values, but the intersection worked at this point here, which is 8. They both have 8 here, right? You can see from 8 we have 4 and 5, right? And we also have 4 and 5 from this point. So it is good. It is good to. Oh, I've not submitted this. Jesus. Let's see what this is going to give us. I'm sure it's going to be slow in terms of space. Yes. Space is slow. The time complexity here, right, is O of n plus m, because we are this here is O of m, or n if you will, and this other one too, so it's another O of n or m. So two separate nodes, two separate loops, right? But the space is terrible. So we'll look at improving this tomorrow. Anyways, I've learned something today, really important. I'll push this to GitHub for git add git commit dash m. This is a linked dash list. Come on. Linked list, and this is lit code 160 or 160, yes. Lit dash 160 git push origin main. The main origin. All right. Thank you guys for watching. It's been an absolute pleasure to have done this stream today. I'm quite excited because of what I just learned now. It is just really exciting me. I don't know why it is exciting me, but it is good. Anyways, thank you guys for coming through. Thank you guys for also learning, right? You guys are also learning. And I will see you tomorrow. Stay coding. Bye. Hey, don't forget to join the Discord channel. There are a lot of awesome people there. You can meet people there and discuss programming topics, anything at all programming related. Make friends, share knowledge, share data structures and algorithm. uh Anyways, don't forget to subscribe if you are here. I've not said this before, but for the first time, I notice most of you are not subscribed. Why? Why are you not subscribed? Tell me. Subscribe and like the video. And like the video. I'll start saying subscribe and like the video, right? I keep forgetting to say it. Anyways, and I still have, you know, awesome people here. I know you guys are nice people. Don't forget to subscribe for more streams, data structures, and algorithm. I'm excited. I don't know. I'm excited. Okay, don't forget to like and subscribe. Once again, like and subscribe. Bye. Okay, how do I end this? This is the awkward part. You just say bye and the stream is not ended. Okay, I can see. Yes, tomorrow I'll wear a yellow shirt tomorrow. I'll take that. Ransom, I'm wearing a yellow shirt